Okay, now let's get started on acid and bases. Okay, so with the notes, let's go through the page 1. Now, in this chapter of acid and bases, now there is a reason why just now there was a chemical bonding crash course, and then now this session is on acid and base, because you will realize that acid and base is a very interlinked chapter together with chemical bonding, and it is very important for you to know what is the basic for this chapter, the previous chapter, which is chemical bonding, before learning about acid and bases. And hence, I structured the lesson in a way such that chemical bonding comes first, followed by acid and base. Okay? Now, let's start off with what are acid. Now, just now we discussed about covalent, ionic, metallic, right, in bonding. Now, for example, I give you an example. I have a covalent molecule. Now, I have a covalent molecule, and this molecule is known as HCl. Now, how I know it is covalent? Very simple. Because covalent is always between non-metal and non-metal, right? Non-metal and non-metal. So hydrogen is a non-metal, chlorine is also a non-metal, right? For new students who have just joined us, just now I was explaining, on the left-hand side of the periodic table, okay? On the left-hand side of the periodic table, this is where the metals are located. On the right-hand side is where the non-metals are located. Can I? Okay, now back to the slide. Now, if I have a covalent molecule, HCl, this forms the basis of why does acid actually take place. Okay, now covalent, you may be thinking, now let's look at the definition of acid. It is a substance that produces hydrogen ion in water. Okay, remember, acids, they produce this thing called a H+ ion. Okay, key concept number 1 is you need to understand that acid produce H+ ion when in water. Now, if I look at this covalent molecule over here, you may be wondering, okay, this one covalent, why got ion? Why suddenly got ion come out? This HCl, I'm telling you, it is going to be an acid. Now, how? First off, just now, based on just now lesson, can anybody tell me, this HCl over here, what kind of structure does it have? Is it a SMS, GMS, etc.? Can somebody write? Okay, very good, YJ. It's a SMS. Okay, simple molecular structure. Thank you, Andy, also. Now, it is a simple molecular structure. And that means that this molecule itself, okay, this molecule itself is a covalent molecule that exists by itself like this. Simple molecular structure also means that they got low boiling point and low melting point. Okay? So for this itself, HCl, at room temperature, it is a gas. Hydrogen chloride gas. Now, but what is so interesting about this is that, for example, I have HCl. Now, I write over here, HCl gas. Now, if this gas, I try and bubble it into water. Okay, I dissolve in water. Okay, aqueous solution. Aqueous solution is just water. Okay, what happens is when I convert this and I dissolve it or I infuse it into water, it is going to give me this thing called HCl aqueous. Aqueous hydrogen chloride. And that is also known as hydrochloric acid. Okay, hydrochloric acid. Now, why does this actually take place? I'm going to share with you. Now, if we are looking at HCl, we see that we have H+ and we have Cl-. How does that actually work? So I say already got 2 stages. Now, stage number 1, the HCl gas, whatever that I write on top, will become HCl aqueous. This is when I dissolve into water. So on a picture perspective, it looks something like this. So I got a beaker of water. Now, what happens is when I put this HCl molecule that is outside in a gas, I put inside water. Now, what is going to happen in stage number 2 is something that is very special. And this process is known as ionization. Now, it turns out that, okay, this HCl aqueous is going to undergo ionization. That means that this is actually going to separate. And when they separate, they are not separating into atom, they are actually separating into ion. So hydrogen will become a H plus ion. This is in solution in water. And the Cl, the chlorine, will become a chloride ion in aqueous solution also. Okay, you understand me so far? Now, what happens next is that you can observe from here that this is going to become a positive ion and the chloride is going to become a negative ion. Now, after this process have happened, this H plus ion is whatever the one that I'm actually looking out for. Because there is this H plus ion, it gives acids its properties. Okay, now we're going to look at properties of acid later, but most important for you to know is that there are three main types of acid, and the three acids are as follows. Number one, hydrochloric acid. Number two, sulfuric acid, and number three, nitric acid. Now, these are the three common types of acid you will use in lab, okay, when you go for chemistry lab. Now, hydrochloric acid is HCl. Okay, write this down. Sulfuric acid is H2SO4. And nitric acid is HNO3. These are the chemical formula. This I need to remember. So sorry. This is the first and only rare case that you need to memorize. Okay. All right. Now, a little bit more information of acid. When dissolved in water, look at this carefully. There will be different acid that form or produce different number of H plus ion. Now, these, remember, HCl, one HCl, look at here, one HCl give you one H plus ion. This is a 1:1. However, let's look at this one, H2SO4. Remember, in one H2SO4 got two hydrogen. That means that the hydrogen can come out, become 2 times the number of H plus ion. So means I got one sulfuric acid can form 2 H plus. Okay. Now, with this understanding, the basicity of the acid, this term refers to the maximum number of H plus ion that is produced by a molecule of the acid. Okay. Now, I'm going to explain this slightly more later. Let's move on first. There's two conditions. Okay. For students, we need to copy. Please copy first. Okay. The rest of you, are y'all good? If good, can give me a thumbs up. If not following, can ask me to explain again if you need. Okay, Andy, very good. Charlene, okay. All right. Okay, great. Now let's move on to the next part, which is talking about strength versus concentration. Now, sometimes when we study this chapter, we say that the strength of acid and concentration of an acid is very confusing, right? Some of the thing, like for example, I say, oh, is this a strong acid or is this a concentrated acid? Does it mean the same thing? Actually, it's very, very different. Okay, now I'm going to break down the confusion for you and tell you that what does strength of acid mean and what does concentration of acid mean. They are very different, okay? Now, acid can be strong, can be weak. Like every human being, they can be strong, they can be weak. Okay, now what happens is that when we say that there is a strong acid, now strong acid, they are going to undergo complete ionization in water. Now, what does this mean? That means I have a beaker over here. Now, outside I got HNO3. When I put inside, if I put in HNO3 and HNO3, when I put in, they will give me H plus and NO3 minus. Okay, basically every one of the HNO3 I put in, they will separate to become ions. Understand? Now, how do I know this is minus? How do I know this is plus? Very simple. Okay, now I give you an example. HCl give you H plus, then of course the remaining one, chlorine, must be minus because plus and minus becomes 0 right? So same goes for HNO3. HNO3 will give you H plus and NO3 minus. Okay, so Basically, this charge must cancel out. Get me so far? All right. Now, a strong acid is what is illustrated in purple over here. Let's now talk about a weak acid. Now, a weak acid is different because they partially ionize in water. What does that mean? I give you same scenario. I have a beaker. I give you the same scenario. I have a beaker. Now, I got this weak acid. It is called vinegar, CH3COOH. Otherwise, chemists call it ethanoic acid. Okay. Now, I got CH3COOH. I got 3. Now, what happens is it turns out when I put this inside the beaker of water, remember this is water. Now, what happens is that, okay, number one, this one will go in, they will separate. Then hence, this hydrogen become plus, and this one become minus. Okay, now HCO, this one, the CH3COH is slightly different. We say HNO3 is H plus, the one at the front, right? This one is at the back. Okay, H plus is at the back. Okay, now, first one I put in, okay, fantastic. They separate. So I got one H plus over here, I got one CH3COO minus. Now, what happens next is that when I put in the second CH3COOH and the third CH3COOH, it turns out the 2 molecule of acid that I just put in these 2 over here, they actually don't become H plus. They don't give you H plus. Hence, I call this a partial ionization because some of the acid I put in, okay, become H plus. Some of it it actually don't become H plus. All right. So that means that at the end, I will have a mixture of ethanoic acid, which means is this CH3COOH. I will have a mixture of hydrogen ion, which is this H plus over here, and this is a ethanoic ion. Okay. Now, sound confusing to you, right? No worry. Let's move on a little bit. Now, when we say HNO3 is a strong acid, they undergo complete ionization because every molecule of the acid become H plus. Get me? So all of the acid become positive ion. Now, what if I have a chemical equation that is for the dissociation of weak acid? Now, weak acid, for example, this one vinegar, I tell you already. Vinegar. Now, when I write the equation, I cannot put full arrow. I put full arrow means every time I throw the vinegar in, it will give me a H plus. So this one should give me a H plus, give me a H plus also. But what happened is, since these two actually never give me any H plus, right? Only one out of the 3 ethanoic acid give me a H plus, I will put a reversible arrow. Now, this is known as a reversible arrow, means 2 head, one to the front, one to the back. Okay, now they got H plus and CH3COO minus. Okay, now later we will practice on writing this equation, not to worry. Okay, now you are maybe a little bit confused. Let's try and understand this first. Okay, now I have a picture later to show you what is going. Now, strong acid does not mean concentrated acid. Now, concentrated acid simply means how much water I add. How much water I add? I add more water means it's more dilute, right? I add less water means more concentrated. Like for example, when I make Milo, okay, I at home make Milo, right? Now, if I put Milo powder, I put 100 ml of water, give me very concentrated. But if I put the same amount of Milo powder, I put 200 ml of water, then become very dilute, right? Same goes, okay, same goes. Okay, so the amount of water I add to the acid molecule. Okay, now similarly, the weak acid does not mean dilute acid, and the strength of the acid depend on extent of ionization. Now, this is a new term. You need to take note of this. Now, extent of ionization means what? A strong acid is going to undergo full ionization. Okay, full ionization for strong acid. Now, for weak acid, it's going to undergo partial ionization. This is for weak acid. Okay, weak acid. Okay. Now, what about concentration? Now, concentration simply means chemistry definition depend on amount of solute in the solution. Now, the word solute over here refers to whatever we are dissolving inside the water, which is the acid molecule. So it means, for example, I give you an example. I take this, okay, this scenario over here. I copy and paste. Okay, yeah, no need draw, just listen to me. Okay, now I got two scenario over here. Now, look at this over here on the right hand side. Now, in this case over here, if I were to add in, for example, let me just clean this up a little bit, okay? Little bit. Now, the one on the top, A. The one at the bottom, B. The one at the top, I add in 2 molecules of acid inside, 2 molecules of nitric acid inside. But the one at the bottom, I add in 3 molecules of nitric acid. And I tell you that this one inside got 1 liter of water. This one inside got 1 liter of water also. Now, can anybody tell me A and B, which one is more concentrated? Type in the chat. Which one is more concentrated? Okay, thank you, Andy. I see your answer. Thank you, YJ. I see your answer. Anybody else? Try this. A or B? Which one is more concentrated? This one I got 3 molecules of acid. This one I got 2 molecules of acid. Okay, Talina say B. Okay. Anybody have different answer? Sarah say B. Okay, C say B. Okay, very good. Fantastic. Okay, so you understand, when I got more molecule of water, more molecule of acid, that means for the same amount of water, it is more concentrated. My question changed now. A and B. These two are acid. These two are acid. I remember HNO3 is nitric acid. Okay. Now, when I put in to this one, can you tell me A or B? Which one is stronger? Now I look at strength. Okay. Now look at strength. Which one is stronger, A or B? Okay, YJ, very good. Okay, Charlene. Okay, Valerie. Okay, Andy. Okay, I see your answer. For those of you who say A, why A? For those of you who say B, why B? For those of us who haven't given me a reply, can give me a reply? Okay, just kidding lah. Okay, but y'all just think about it. Is A stronger or B stronger? In this case, strength. Okay, Andy give us a very good point. Okay, I say again. Now, acid can be strong or weak. So if I give you the same acid, the strength of the acid is exactly the same. No matter how much acid I put in, I put 3 molecules of acid, I put 2 molecules of acid, it is still the same acid. And that means that the strength of the acid is the same. Strength means what? Strength is either it's a full arrow or a half arrow. This one is a weak acid. This one is a strong acid. Remember, strong acid will go full dissociation. Weak acid, it will go partial dissociation. Okay, partial dissociation like this one over here. Okay, so at the end of the day, A or B, which one is stronger? Actually, it's the same because this one is HNO3, strong acid. This one also HNO3, strong acid. Strength is the same. Get me so far? Okay, any question? If okay, can give me a thumbs up. Okay, thank you, Hiwon. Thank you, Talina. Thank you, Charlene. Okay, Andy, okay. Okay, YJ asked a question. I think some of you have the same question. Now, your school may use this word, dissociation. Okay, this one, dissociation. And in this case over here, I use ionization. Okay, these both two words are exactly the same. They mean the same thing. Basically, if I got an acid molecule, I associate together, means together. I dissociate means I break apart. When I have an acid molecule, when I make it into ion, I ionize. So it's the same. Okay, ionize and dissociate can be used interchangeably. Some schools like to use dissociate, some schools like to use ionize. For me, I prefer to use ionize. Why? Because it's telling me that it's going to become ion, H plus ion. Okay, can I? Okay, moving on. Now, next one I'm going to show you is a picture. Now, tell me, 1, 2, 3, 4. You tell me, this is a strong or weak? This is a concentrated or dilute. Okay. Now, let's try for, okay, let's look at the picture first. Let's try for strong and weak first. So for example, if it's 1, 2, 3, 4, if it's strong, strong, weak, weak, type SSWW. If it's weak, strong, type WSWS. Okay, try and get these 4 first. Okay, let's try this. Wow, YJ, so fast. Okay, let's wait for some people else, some other people. Okay, got questions? Andy, your question. Yes, you have to use the right keyword. Okay, I see a lot of answer. Okay, I see Charlene answer, I see Valerie answer, Marilyn answer. Okay, very good. So most of you managed to get it correct. So for strong acid, this is a strong acid. Number 1 is a strong acid. Number 2 is a weak acid. Number 3 is a strong acid. Number 4 is a weak acid. So now we understand strength of acid depends on the identity of the acid itself. Okay, let's write this down. Depend on identity of acid. I tell you the name of the acid, you can immediately tell me whether it is a strong acid or it is a weak acid. In this case, because HCl is a strong acid and CH3COOH is a weak acid. How do we know? Remember, strong acid undergo full ionization. That means every single acid molecule is separate into ions. But you see, look at number 2 and number 4. Look at number 4 especially. Only 1 out of the 3 is become ion. The rest are still a molecule. The rest are still molecule. And hence, this means that weak acid undergo partial dissociation. Keyword is partial dissociation. Now, row 1 done. Very good. Fantastic. Excellent. Now, time for row 2. If it's concentrated, you put CDCD or put DCDC. Try this. Okay, and D, I see your answer. Anybody else? Try. Okay, later, Valerie, I'll answer your question. Okay, very good. Very good, Valerie. All right. Now, most of you get the correct answer. It is concentrated dilute. 1 and 2 is concentrated. 3 and 4 is dilute. You ask me why. Now, look at this. Now, concentration simply means the number of acid molecule, or rather number of acid particles in same volume. Okay, so what I mean by this? 1, 2, 3, 4, the volume in the beaker is exactly the same. It's all same volume, right? No difference in volume. Now, if I got more acid particle, right? More acid particle, that means more cluttered. You look at number 1. Number 1 look very cluttered, right? Because there's really too many acid molecules. See, 1, 2, 3, etc., etc. A lot per unit volume. Look at comparing the number 3. Number 3 only got 2, right? Only got 2. And clearly see that concentrated one means it's very full, right? Very full, a lot of acid particle. Now, 3 is dilute because only got 2 ma. Now, if you don't understand this, I'm going to give you another example using Milo. Remember our Milo packet? Milo packet. I pour inside the cup. Milo packet, I pour inside the cup. Milo powder. Now, if I add, Milo powder inside the cup, inside the cup. I add a little bit of water only. Then that means what? My Milo powder only have this amount of space to work with, right? My Milo powder only got this small amount of space. However, if I got a cup, the Milo powder is here, okay? I pour a lot of water. My Milo powder got this whole area to work with, right? It can distribute itself in this whole area. Then this one, obviously, it become a dilute Milo, right? The Milo got no taste one. But if I put small volume, this will be a very concentrated Milo. Okay? I hope you are able to understand this. Now, I got another question from, does the amount of ions presented represent the volume? Mary, I don't get your question. What do you mean by the amount of ions presented represent the volume? No, the volume is exactly the same. You know the concentration, I said the volume of water is exactly the same. Then in this case, 1, 2, 3, 4, all got same volume. Maybe this one inside got 250 ml. This one also got 250 ml. Okay. So what I'm only counting, no worries. What I'm only counting is this. Like that, I got 1 acid molecule. Like that, I got 1 acid molecule. Like that, I got 1 acid molecule. So I got many inside here, inside this same volume. I compare to this one, I got 1, 2. Right? Very little. So this one got less. This one got more. So the more one is more concentrated. The less one is less concentrated. Okay, I got another question. So what does identity of acid means? What does identity of acid means? Now, I'm going to show you an example. Now, there are many acids in this world, but what is more important? What is more important? Let me just zoom in a little bit. Now, maybe you want to write this down. Acids. There are some acids, there are strong acid. There are some acids that are weak acid. Now, strong acid, I'm going to give you an example. This one, unfortunately, we need to remember. Strong acid, number 1, HCl, hydrochloric acid. 2, H2SO4, sulfuric acid. 3, HNO3, nitric acid. So most importantly, you just need to remember these 3. These 3, when you hear hydrochloric, sulfuric, and nitric, most of it all have a H in front one. They are always strong acid. Now, strong acid means what? Once again, they undergo full ionization. And whenever we have full ionization, it's a full arrow. It's a full arrow when we write the dissociation equation. So for example, HCl looks something like this. We give you H plus and Cl minus. This is for strong acid. Everybody get this? Now, moving on to weak acid. Now, I give you 2 examples. The first example is CH3COOH. This is known as ethanoic acid. Sometimes people call vinegar also, same thing. The other one is H3PO4. This is known as phosphoric acid. This one very uncommon. Very uncommon, very rare. But good to know. Most important is weak acid. You just need to know that they undergo partial dissociation or partial ionization. So sorry, my handwriting a bit terrible today because the pen is not working very well. Now, for weak acid, they undergo partial dissociation. That means that whenever we talk about ionization, it's always to form what? It's always to form H plus. is always to form H plus. We are always looking for H plus because acid is always about the H plus. And hence, look at this weak acid. Now the equation looks something like this. CH3COH undergo partial dissociation to form H plus. So I take out the hydrogen already. Okay, then the rest I put CH3COO minus. Okay, just treat it as it is one thing like that. The H is standalone. Okay, so I just take out the H, then everything else is a minus. Can I hope I can understand this. So identity of acid means what is the acid? If it's HCl, definitely a strong acid. H2SO4, definitely a strong acid. Based on what the acid is, it tells us whether it's strong or weak. Can okay. Andy, your question. Ammonia is a base, it's not an acid. Okay? Okay, moving on. Very good. Okay, so you all managed to get this right just now. This is a concentrated strong acid. This is a concentrated weak acid. This is a dilute strong acid, and this is a dilute weak acid. Okay, remember weak acid still exists as molecule. They haven't dissociated out. Not all dissociate out. Okay, okay, now we are going to move on. Now this page, I understand it's not inside your notes, okay? But I put this photo over here to help you to understand it from a visual perspective. Because a lot of us are visual learners, we like to see photo, we like to see, so that you see, very simple, I draw out like that, then you all can tell me SW, SW, or CCDD, huh? So it's easy for us to learn. Okay, now let's come to the first practice question. Now, this practice question actually look very long, right? Actually, it's okay. I'm very simple one, but I need you to read. Okay, I need you to read. Now, the question says I have hydrochloric acid, nitric acid, and ethanoic acid. They are monobasic. They are monobasic acid. Then sulfuric acid is dibasic acid, and phosphoric acid is a tribasic acid. Now, they give you these three terms. Just now I talked about basicity, right? Remember, I talked about this term, but very briefly. I never really say much about it. Now, basicity is simply referring to the number of hydrogen ion, okay, per acid molecule. Okay, when it is ionized. Now, what does that mean? It means basically when I write the equation, on the left-hand side, I got one acid molecule. How many H plus I get at the end? Okay, so let's read this question first. Give you a minute to read the question. Then later, we are going to discuss this. Okay, monobasic, dibasic, and tribasic. I highlight the one that is more important for you. Okay, nitric and ethanoic, they are all monobasic. Sulfur is dibasic. Phosphorus is tribasic. Think about it first. So basicity is referring to number of hydrogen ion. I give you another 1 minute to think about it. Then we'll go through. I hope that all of you are following. If you have any questions, please feel free to ask inside the chat. Okay. All right. I think most of you are thinking already. Very good. So they're asking us, what does monobasic, dibasic, tribasic mean? Okay, so let's define for them. Now, monobasic. Let's look at the equation. Now, monobasic, what is monobasic? For example, I take hydrochloric acid as example. Now, 1HCl, this is the dissociation equation or the ionization equation, okay? Now, that means, what does dissociation equation mean? It means I got one molecule of acid become how many molecule of any other substance? So look at this. I got one acid molecule. It is going to form me one H plus. Okay, 1:1. Now, HNO3, 1:1 as well. Okay. Last one, ethanoic acid, 1:1, same. Now, sulfuric acid on the other hand, look at this. One sulfuric acid give you 2 H plus. 1:2. Phosphorus is even more. 1:3. And that means the basicity, as I mentioned just now, is refers to the number of H plus when the ionization occurs. Okay, so after ionization occur, I see how many H plus we have. Monobasic acid simply refers to 1 mole of acid produces 1 mole of hydrogen ions when dissolved in water. Okay, so I'm going to write, I've already written the one down for monobasic. Then for dibasic and tribasic, I leave you to it. Dibasic simply means 1 mole of acid produces 2 mole of H plus. Okay, now I know some students in Sec 3, they haven't learned about mole concept yet. Not to worry. Okay, basically, you just tell me one acid molecule, okay, produces 1 H plus molecule. That's all. Simple. Okay. So monobasic, dibasic, tribasic is same. 1:2 and 1:3. Di is 2. Tri is 3. Can I? Okay, moving on. Okay. Any other question? Okay, if any question, please ask. Now, moving on to bases. Notes next page. Now, bases are oxides or hydroxide of metal. This is the definition of a base. Very important. Oxide or hydroxide of metals. Or some school, they say metal oxide or metal hydroxide. Same thing. So what does this metal hydroxide or metal oxide actually mean? So for example, copper oxide, for example, sodium oxide, sodium hydroxide, they are all bases. They are all example of bases. Okay. Now, bases is the general category. Okay, acid and base. Under bases, there is this special group. Now, bases got 2 types. Look at this carefully. I have a base. If the base is soluble in water, means I put inside water, it can dissolve. Then I call it alkali. Okay, I call it alkali if it can dissolve in water. Now, if it cannot dissolve in water, then okay, I call it a base, insoluble base. Okay, no special name. Only when they got the special power to dissolve in water, I call it special name, alkali. So all alkalis are bases. Okay, alkali is a base, but not all bases are alkali. Get me so far? Alkali can dissolve in water. Okay, bases got 2 types. One is soluble base. Soluble means can dissolve, it's called alkali. Insoluble means cannot dissolve, it's called insoluble base. All right, so this is an important definition that all of us are required to know. Now, the next thing for us to understand is what are these soluble bases actually about? What is this alkali? Now, just now we learned about acid. Acid is, for example, HCl. They will dissolve. This is an acid to give you H plus and Cl minus. Now, this happens in solution in water. Now, this same principle will apply for base. So for an alkali, what I call alkali now? Well, bases got insoluble and soluble. Alkali are the soluble one. I no point I say insoluble base cannot dissolve in water anyway, right? So alkali For example, sodium hydroxide, okay, they dissolve in water. What happens is that it will form sodium plus ion and OH minus ion. Now, the key thing for alkali, when you see this hydroxide, OH, this is where you know that this is an alkali in a aqueous solution, means can dissolve in water. Now, so hence the definition goes like this. Alkalis are substances that produce hydroxide ions when dissolved in water. Okay, hydroxide ion is this OH minus over here. Okay, this OH minus over here. Now, same for acid. Acid is because of H plus. Okay, same for acid, acid is for H plus. For base, it is OH minus. It is precisely because there is OH minus, that is the reason why alkali got alkali property. Okay, alkali got property of alkali because of this OH minus. And I know that because I learned about strong acid and strong base, strong acid and weak acid, the same principle apply for alkali. So I got a strong alkali, which means it completely ionized in water. I also have a weak alkali, which means it partially ionized in water. Okay, now what is an example of weak alkali? It is ammonium hydroxide. Okay, this is a weak alkali. You will find this on the next page of your note. I think it's an overlap. Okay, now, Andy, your question, what if it's sodium oxide, right? Sodium oxide. Now, sodium oxide will dissolve in water. It's not just story, right? So now we handle from this situation first, right? Where we don't add, where this thing can immediately you can see the OH. Your one is slightly more complicated. Okay. Now, with this understanding of bases and alkalis, let's move on to indicators and pH. If I give you a solution, this is a solution, maybe X. I want you to tell me without drinking it, tell me whether it's an alkaline or acid. Okay, tell me whether it's alkaline or acid, right? I drink lemon juice sour, but it's got acid. No, I cannot, because maybe this actually is a very poisonous drink. I don't know, I cannot drink to tell, man. So that is the reason why scientists actually invent this thing called indicators and pH. Now, indicators, as the name suggests, they will indicate whether or not something is in an alkaline or something is in acidic. Whether something is acid or alkaline, basically. Now, we learn about these few indicators. Now, I want you to take note of this. What is the most important one is methyl orange. Now, methyl orange is what we use a lot of times in chemistry laboratory. So, methyl orange in a low pH color, which means it's in acid medium. Okay, it is red in color. High pH color, which means it's alkaline, is yellow. Okay, by the way, I haven't shared with you the pH yet. pH neutral is 7. Anything to the left of 7, from 1 to 7 is acidic. From 8 to 14 is alkaline. Okay, 8 to 14 is alkaline. Okay, now this 0 here, you will never come across an acid which has 0 pH. Okay, pH of 0 cannot. Okay, so most probably it will be 1 point something, which is the strongest acid, right? There will never be an acid in the world that is at pH of 0. All right. Now, with this understanding, now why I point out to you methyl orange is because in SEAB, okay, for O-level practical, they always like to use methyl orange. In your school practical, they also like to use methyl orange. This is an indicator that's becoming up and up ever again, right? Now, if they give you an indicator that is not usual, right? Indicator that is not usual, like this, bromothymol blue of phenolphthalein, what happens is usually they will tell you at the endpoint what color is it. Okay, at the endpoint what color is it. But for theory-wise, you are expected to understand and learn all the colors. Okay? Now, Andy, I saw your question. Let's leave it later a little bit more because we'll cover it later. Okay? That one will concern a little bit more about properties. So indicators, just study this first. Now, pH is a measure of acidity or alkalinity. Now, learn these two terms. acidity and alkalinity, basically measuring whether something is an acid or alkaline. Now, when question asks define pH, this is the answer that you give. pH scale is from 1 to 14. Okay, very rare you will see 0 lah, or you will never ever see 0. In fact, pH 7 is neutral. This is a pH of pure water. Less than 7 is acidic. More than 7 is alkaline. Now, remember acidic will always be because there is a lot of H plus. Now, alkaline is always because there's a lot of OH minus. Now, I want to ask you all a question. Okay, I want to ask you all a question. If I have an acid, for example, HCl, can somebody tell me, is this a strong acid or a weak acid? HCl, strong acid or weak acid? Okay, very good. YJ, I see your answer. Okay, Valerie, I see your answer. Very good. It is a strong acid. Now, strong acid, based on whatever we discussed just now, what happens is that they are going to dissociate to give us H plus and Cl minus. This is what everybody understands, right? It will dissociate to give you H plus and Cl minus. But what actually is the more burning question is, since I got this H plus and Cl minus combination inside the solution, they are called acidic, right? But you think about it, does acid only have H plus? Do they actually have OH minus inside the acid? Do we have OH minus actually floating around in the acid? Answer, thank you, Andy. Answer is yes. Why? Remember, this is water. This is water, okay? Everybody understand? This is water. Water is H2O. So I have a H plus and Cl minus over here, okay? Now, I got H2O. What happened? It is going to become H plus OH minus. Remember, because water can dissociate to form this, right? Because I got one positive, one negative. So hence, in the solution, I got H plus OH minus. That's why water is pH 7, because it's a combination of both H plus and OH minus. Remember, alkaline always give me OH minus. Acid always give me H plus. So water is when the number of H plus is exactly the same as the number of OH minus. And that is the reason why water formula is so special, is H2O. So in the solution of an acid, there might be molecules of water, or rather most of the time, there are molecules of water. And that means that you can never tell me at pH 1 only H plus is present. This will never be true. There will always be a very small amount of OH minus. Because yes, acid, correct. Acid got a lot of H plus, but there's still water. If not, you dissolve in what? Right? You dissolve in water, definitely there will be OH involved. Okay, so the definition goes like this. pH less than 7. Solution with less pH is more acidic. And the key word is there is more hydrogen ions than hydroxide. Maybe you want to fill in these ions. Okay, number of hydrogen ion is more H plus. Remember, H plus is hydrogen. Hydroxide is OH minus. Similarly, for solution with a higher pH, this one over here, higher pH is more alkaline, and they contain more hydroxide ions than hydrogen ion. This is a common misconception. People would tell me, hey, my pH 1 pH 1 means I got a lot of H plus. Then got OH minus now. Actually, it's have, but very little. Can? Okay. Now, let's learn about importance of pH. This is something that MOE like to put in, right? They'll just ask you, oh, what is the importance of pH? Okay. Importance of pH, yes. Preserve vegetable, low pH. When we use ethanoic acid to preserve vegetables, okay, for example, you have all those so-called preserved vegetable that you buy from a supermarket, etc. You always see ingredient list, there's ethanoic acid involved. Now, there are some plants that can only grow at certain pH levels. And next one is using solution of different pH for hair perming or conditioning. So for example, people who like to curl their hair, okay, they use solution or chemicals of pH that's very low or very, very high. This is to ensure that okay, the hair can change its the structure of the hair will be able to be altered because of the differences in pH, right? Either stronger acid or stronger base. Now, to measure the pH of a solution, I use this indicator, cannot measure exact pH. It can only tell me whether it's an acid or alkaline because in this transition, they will after that, okay, for example, I give you 7, pH 7, okay, that means yellow. Give pH 8 is also yellow, right? You would not tell me what is the exact pH. But using universal indicator or pH paper, sometimes I call universal indicator paper. Okay, this will tell us exactly what is the pH of a solution. So what happened is, for example, I got a conical flask over here. I got solution Y. I don't know what is the pH. I take a piece of universal indicator paper. I drop a little bit of solution on the universal indicator paper. Now, if the universal indicator is like, the paper turns very red, then we know, okay, pH 1. Lor. If the paper turns maybe like purple, then okay, maybe acidic. Alkaline. Okay. Now, Andy got a question. Do you need to remember what is the exact number for this? No, no need. No need to remember the exact number. You just need to tell me, okay, methyl orange, right? The transition is in the acidic range. But most of the time, you will not get tested on this. Like you'll just be tested in alkaline, what is the color? In acid, what is the color? Okay? Can You meant the importance of pH. Plants grow best at 5.6. Okay, this one is just for information only, just for your information. Okay, you can tell, okay, when they ask what is the importance of pH, you can say some plants grow well in slightly acidic condition. Okay, this number no need to remember. Okay, just there for your information. All right, moving on. Any question? No question, then move on already. Yeah. Okay, now practice question number 2. Try this. This one quite simple. Very fast can give me answer. A, B, C, D. Okay, try this question. Yeah, I think most of you have gotten your answer. All right. Very good. I see a lot of answers that are similar. Okay, great. So for this question, why are the pH values different? You are definitely right to say that ethanoic acid undergoes partial ionization. Okay, because of the reversible arrow, since ethanoic acid is a weak acid, and hence the pH value is higher. Okay, now size of molecules doesn't matter. Releases fewer H plus ion. This is wrong, right? Because all of the HNO3 will become H plus. Technically, CH3COOH will give you less H plus because more of it are in its molecular form. No charge, right? No ions. Now, I got a very good question, right? Does the pH of acid always stay the same no matter how concentrated or diluted the solution is? Okay, this is a very good question. So if you ever think, I say, okay, strong acid, pH is close to 1:3. Then weak acid is like 4:6, right? So remember, this is strong acid. This is weak acid. Now, then after that, I say, hey, if I got strong acid, I got concentrated versus dilute, will it change or not? Yes, the answer is yes. But at your level, okay, for O level, no need to know. Okay, no need to know. You just need to know for strong acid is 1:3. Okay, closer towards 1. Then weak acid is 4:6. Okay, it's 4:6. All right. Okay, great. So question 2, very good. Okay, let's try this. Question 3. Okay, try question 3. Then quite fast, quite fast. This one is what we discussed just now. Should be quite fast. Okay, good. I see some answers. Very good. Okay. Wow, got somebody give me V as the answer. Only got A, B, C, D. Okay. Good, good. Okay, good. Okay. All right. Most of you get the correct answer, but there are some of you who didn't manage to. Okay, come, let's discuss. Now, I got a strong acid HX. They contain molecule of water. Why? Because it is dilute. Dilute means I add a lot of water inside, right? Ions H plus and X minus. Now, number one, pH value of acid above 7, definitely wrong. Acid is less than 7, right? Confirm plus chop. Everybody know this. B, solution also contain a high concentration of HX molecule. That means I'm talking about this thing not working because I still have this at the end, but everything already become ion. So this is wrong, right? No more molecule. This is the molecule, but it doesn't exist anymore because all become ions. Now C, also contain OH minus. Yes, correct, because I got H plus OH minus that forms water. Last one, more H plus than water molecules. No, because I say it is a dilute solution, means a lot of water, a lot of H2O. Okay, a lot of water. Can? Okay, now let's move on. Okay, let's move to physical property. Okay, now this one is the one that most of you are, it's quite interesting. Okay, you will learn this. So acid have a sour taste. Okay, alkali have bitter taste and slippery feeling. For example, like soapy feeling. Now, dilute acid are irritant, concentrated are corrosive. Same for alkali. Now, just now I got one question about litmus paper. Acids, they turn blue litmus paper red. Okay, they will turn blue litmus paper red. Okay, come. So sorry, Okay, it will turn blue litmus paper red. Now, alkalis will turn blue, okay, red litmus paper blue. So what I recommend student, you will always get confused, right? Just remember, acid, universal indicator, right, is on the left, right? Universal indicator is red. Then okay, you just say N color for acid, it will turn red. Hence, if it turn red, that means I need to use blue litmus paper, right? I cannot be using red litmus paper, then test, then it will still be red. So I use blue litmus paper, I test for red. Now, alkalis on the other hand, become blue. So you remember that table over here, right? It's more towards the blue side, right? Over here. Okay, so alkalis, blue, and acid, this one already said. pH more than 7 is alkali, pH less than 7 is acid. Now, acid and alkalis, both they conduct electricity. Both conduct electricity. Now, okay, Andy asked what does caustic mean? Okay, so just a very serious injury. Okay, no need to know. It's just an acid burn. It's like acid burn, alkali. When you spill chemical on yourself, it's very corrosive. Okay, now remember, acid and alkali, because they're in water, okay, they are ionic. And because they're in water, all of them have mobile ion. Now, when there are mobile ion in solution, positive or negative mobile ion, what happens is that it's able to conduct electricity through the solution. Okay? Okay, moving on. This is physical property. I think most of you know this already. Now, this one is the one that most of you are confused with. Now, chemical property and reaction. Now, there are a total of 1, 2, 3, 4, 5, 6, 7, 7 reaction that you need, right? But not to worry, not to worry. What is most important over here is number 1 for both sides. Number 2, number 3, and this over here. Okay, this one is repeated. This one over here is repeated on top. Okay, so actually you only got 6 reactions. 5 out of 6 is very, very important. Okay, now I'm going to bring you through one of each of them very carefully. Let's start. Acid plus metal give you salt and hydrogen gas. Okay, now this one everybody know. Acid metal give you salt hydrogen gas. For example, HNO3 nitric acid react with calcium. They'll give you calcium nitrate and hydrogen gas. Now, this identity of the salt, you need to know how does it work. If I put nitric acid and calcium, it gives me calcium nitrate. Okay. Now, acid plus alkali gives you salt and water. How do I remember this? Because alkali, remember, they are soluble base. Means soluble base means whenever it's soluble means got water involved, right? So hence they form water as the byproduct rather than hydrogen gas. Okay, so now gas test for hydrogen gas. Can anybody tell me what is the hydrogen gas? Gas test for hydrogen gas. See whether you all know your practical skill, okay? Okay, lighter spleen. What about the lighter spleen? Keyword, start with E. Extinguish. Okay, lighter spleen. Okay, not enough. Lighter spleen with pop sound. Very good. Okay, so this is your observation, full observation. Tell me that it extinguishes lighter spleen with pop sound. Okay, very good. Now, acid plus alkali reaction. I know acid is less than pH 7. Alkali is more than pH 7. When it produces salt and water, now water, right? Salt and water, they are neutral, right? So hence I call this reaction a neutralization reaction. This is very important because exam, when they come across this kind of question, they'll ask you, name this type of reaction. They must say it's a neutralization. Okay, now moving on. Acid plus metal carbonate gives you salt water carbon dioxide. Carbonate gives you carbon dioxide gas. Okay, alkali plus ammonium compound gives you salt water ammonium gas. Right, so ammonium compound gives you ammonia gas. I put them side by side so that you can see similarity. Carbonate gives you carbon dioxide. Ammonium compound gives you ammonia gas. Okay, now this one is acid-base reaction. Acid plus base gives salt and water. So acid plus metal oxide, acid plus metal hydroxide. Basically, this whole thing is same as this. Acid base gives salt and water. Okay, acid base gives salt and water. All right. Now, I say so much. Actually, no much use because when you do the question, then you need to know. Okay. Now, let's try a little bit of questions. Now, let's try this one, the first one. So I have hydrochloric acid plus magnesium. This will give me magnesium. What? Remember hydrochloric. So chloric come from chlorine, right? So it's magnesium chloride. Right? And since this is a metal, this is a metal plus acid reaction. Acid plus metal reaction give me, yes, very good. Thank you, Natalie. Give you hydrogen gas. Very good. Okay, so how does the equation look like? HCl plus Mg, it will give you MgCl2 plus H2. Now you can see over here that since hydrogen is H2, MgCl2, because magnesium is 2 plus, Cl is minus, so I need 2 chlorine to balance the charge. It will be 2 HCl plus 1 magnesium. Okay, the rest you do yourself. I got no time already. Okay, now there's many practices. I make the practices available for you so that some people they say, okay, I need more practice. For example, I'm not very good with hydrochloric acid reactions. Then I just practice all the hydrochloric acid. Then some people, oh, nitric acid not so familiar. Then I do nitric acid. Okay. Now there are many different types. So for example, this is a metal, this is a base, this is a carbonate, this is a base, this is a base, etc. So I give you many type of reactions so that you can go and experiment with it. All right. Now, last part, okay? Now, uses and application of acid and base in our life. Okay, most important part of the chapter, actually, we already passed it. The most important part is this one, right? Chemical properties. So what are the reactions that involve acid and bases? So with this table over here, whatever question the exam throw you, it can be categorized in one of these seven. So with this table, you always go back and reference to this table, your question, if it's difficult, you can do one. But this one requires a little bit more thinking because many a times O-level don't like to ask questions that you can just memorize. They like to ask like weird question. I know, what is recycling or whatever? Things like what can you do to promote recycling in your community? Sometimes the question is very, very weird phrase one. So when we are chemistry student, okay, what is most important for us is to understand what are the users of acid and base. So if they throw you a curveball, right, throw you a question that is not very common, you can still answer it. Now, first thing for you to understand for acid is that sulfuric acid is very, very important. Okay, they are the most important industrial acid. Now, that means that on an industrial scale, they are used for agriculture fertilizers. This means whenever I plant something, I use sulfuric acid so that I can control the pH of solutions. Detergents, paints, dyes, and plastics, all of these involve sulfuric acid, okay, as a chemical. Now, sulfuric acid also used as a battery for road vehicles. Okay, have you ever opened the bonnet of a car before? Okay, maybe your father is drive a car, or maybe you have seen bus breakdown. You will always see that there's this box, so-called like cuboid box, and then they will have this plug on top, right? Plug on top, so that you can actually restart it if, let's say, the battery got no power. Now, this one inside actually contains sulfuric acid. And other use of acid is for rust removal. Okay, rust removal, why? Because I'm going to use a metal plus acid reaction. Remember, metal plus acid use salt and hydrogen gas. I can take away the metal, right? The metal that have rusted. Preserve food. Okay, preserve food. And remember, acidic food, they are stored in glass, plastic, or clay. They are never stored in metal. You imagine you go to Sheng Siong or go to NTUC, you buy a bottle of vinegar, and the vinegar comes in a metal bottle. Do you dare to use it? Because they say, actually metal will react with the acid, right? Vinegar is an acid, ethanoic acid. Then actually, my acid my vinegar maybe don't become vinegar, become like a salt already, right? Hence, that is the reason why acids are always stored in glass, plastic, or clay. In your lab as well, when you are doing lab experiment, we always store them in plastic container, right? You remember your reagent container always is plastic, right? Seldom is glass because they don't like you to break. Very expensive, okay? So they use plastic. Now, for alkalis, on to the right side. Alkalis, they are used very widely. Every day when you brush your teeth, toothpaste contain alkali, right? It helps to get rid of the bacteria and dirt in your teeth. Soaps and detergents. Now, this one, okay, you go back and see your Dettol, take your Dettol come out. Okay, you will also see, you will often see that there's actually something to do with ammonia derivative, etc. Okay, you know they are used for soaps. Floor and oven cleaners. Okay, these are strong alkalis, help to remove a lot of the basically use the power to corrode so-called the top layer of the floor so that it look cleaner. And there's medicine for indigestion. Too much acid build up, they put in some alkali to neutralize. Okay, so actually acid and base are actually very, very useful. It occurs naturally. You see, I eat an orange, also got acid, citric acid. I eat a lemon, also got citric acid. Every day I wash my hand with Dettol, got base, right? So actually it's not that far off from whatever that we are doing in life. It's just that we never take note of it. Okay, all right. Let's try this question. Last few practice question. Okay, let's try this. Aqueous solution of sodium hydroxide pH 10. Now, first question, sodium hydroxide, strong base or weak base? Is it a strong alkali or weak alkali? Can anybody tell me? Okay, very good. And thank you, Andy. It's a strong base, strong alkali. Now, pH 10, okay, pH 10 closer to pH 14, right? Now, which compounds can be added to sodium hydroxide to decrease the pH? Now, when I try to decrease the pH, that means I need to add something that is pH less than 7. Okay, so what are the possible ones? 1, 2, or 3? Or everything? So what's your answer? A, B, C, D. Try to do this question. Okay, very good. Some people say 1 and 2. Okay, some people say 2. Okay. All right. Okay, most of you say this 1 and 2. Very good, fantastic. Okay. Yes, correct. So sulfur dioxide, when I add water, what does it become? It becomes H2SO4, sulfuric acid. Very good. So acid, good. Good. I need to decrease the pH. Carbon dioxide, when I add water, it becomes what? Carbonic acid, H2CO3. Okay, this is what power your Coca-Cola. That's why your Coca-Cola fizzy. Okay, calcium oxide plus H2O cannot, because it give you calcium hydroxide. It's a base. This one cannot. So hence answer is A. Very. Oxide is not base. Oxide is not base. Only metal oxide. Metal oxide is base. Okay, metal oxide is base. Now, there are 4 types of bases. Maybe I use this to explain to you. Okay, I use my mind to explain to you. Okay, now if you want the mind later, then you just stay for the giveaway. Now, there are 4 main types of oxide. There are metal oxide and non-metal oxide. In the non-metal oxide, there are 2 categories. Number 1 is called the acidic oxide. Number 2 is called the neutral oxide. Acidic oxide, for example, carbon dioxide, nitrogen dioxide, sulfur dioxide. Neutral oxide, water, carbon monoxide, okay, nitrogen monoxide. So you can see over here, the dioxide, most of the time, they are acidic oxide. Acidic means what? Means in the presence of water, they become acid. Okay, so CO2 become carbonic acid, Coca-Cola. NO2 become what? Nitric acid. SO2 become what? Become sulfuric acid. Metals got 2 types also, 3 and 4. Basic oxide is all metal oxide. Now, this is a special. Amphoteric oxide is only reserved for ZAP. Zinc, aluminium, and lead. PB lead is PB. Okay, now these 3 oxides are amphoteric. Now, amphoteric, the meaning means it can react with both base and acid. Now, this is all you need to know. Amphoteric oxide, they can react with base. They can also react with acid. It is just a very short part over here, okay? Just to let you know about oxides. Now, we will learn more about oxides, okay, in future when you go to topics that will involve, for example, your air and atmosphere, etc. But at this point, you just need to know most metal oxide are basic, except for zinc oxide, aluminium oxide, and lead oxide. Then, non-metal got 2 types. All the dioxide are acidic. All the monoxide, 1 oxygen only, is neutral. Okay? All right, back to the slide. Okay, later I still got a few more questions, but maybe we just skip a few more. What I want to show you now, okay, is this part. Okay, let's look at this question. Practice question number 8. Whatever that we learn about oxide, now we apply. Which statement about oxide is correct? So A, basic oxide is an oxide of non-metal. Is it correct? If correct, you say yes. If not correct, say no in the chat. Okay, very good. Thank you, YJ. Very decisive no. Okay, very good. So this is wrong, right? Because basic oxide must be metal oxide. Okay, option B, correct or wrong? Option B. Acidic oxide contain ionic bond. Keyword here is ionic bond. So just now, whatever we see, is there a positive or negative to it? If don't have, then no leh. Remember your NO2, SO2, CO2, H2O. Okay, no, correct, very good. So there's no ionic bond because all of these are covalent. All of these are covalent, okay? They are oxide, so it's an NO2 gas. They are all simple molecular structure, your SMS. Now, C, amphoteric oxide contain a metal. Is this true or false? Okay, I see answers coming. Very good. So this is true because only zinc oxide, lead oxide, and aluminum oxide. These are the only 3 amphoteric. Other than that, there's no other amphoteric oxide. And last one, D. Okay, D, sorry, I should write a circle. C is the correct answer. Basic oxide are always gas, no. Copper 2 oxide is a black solid. Okay, so this is wrong. Can. Okay, so this is question 8. I hope that it helped you to consolidate your understanding a little bit. Okay, I got a request to re-explain amphoteric oxide. Okay, now oxides are amphoteric oxide is special. Okay, so zinc oxide. Now, amphoteric oxide is an oxide that can react with both base and acid. Means it's a two-in-one option, or rather two-in-one kind of a situation. So zinc oxide, I can react it with HCl. Right? Remember, HCl I can react. So I give you zinc chloride. And of course, this is a acid plus base situation. Give you what? Salt and water, right? H2O. So balance the equation looks something like this. This is when zinc oxide react with acid. Now, let's go back to the part whereby you look at this chemical reactions. So, I have alkali, okay, or rather I have metal oxide, right? For example, I have zinc oxide again, once again, zinc oxide. Now, sometimes zinc oxide, they can react. Wait, sorry, the pen is not coordinating. Zinc oxide. Okay, now zinc oxide can react in cases whereby it reacts with bases. So, for example, KOH. Now, how does it actually work? They are going to do a swap. So I get maybe KOH not a very good idea. I use NaOH. NaOH. So what happens is that it is going to give me this thing called zinc hydroxide, ZnOH2, plus it's going to give me sodium oxide. Okay, so it's like a so-called swap situation. Okay, whereby this go here. So this is for amphoteric oxides. Now, end of the day, what is most important? Okay, what is most important? You need to know what are the 4 type of oxide. So first one is that non-metal we got acidic oxide, neutral oxide. Metal we got amphoteric oxide, and the other one is basic oxide. Okay, okay. So I hope that you understand the nature of oxides.